Hi, this is AI Cat. Today we are answering a deceptively simple question. How does data turn into knowledge? The short answer is data itself is not knowledge. Data is more like raw ingredients in a kitchen. Whether it becomes a good dish depends on cleaning, cutting, heat, and practice. Imagine giving a model student records, study hours, sleep hours, homework completion, and final exam scores. At first, the model only sees rows of numbers and text. The first step is turning raw data into a representation the model can compute with. Text becomes tokens, categories become codes, images become pixels or features, and tables become columns. This matters because the model does not directly see the idea of effort. It sees computable clues such as hours studied, submission count, and error rate. So representation is not a boring pre-processing detail. A good representation makes patterns easier to find. A bad one can make the problem blurry. Then training begins. The model uses its current parameters to make a prediction. For example, it guesses what score a student might get. Next, the prediction is compared with the real outcome. If the gap is large, the loss is large. If the gap is small, the loss is small. Loss is not punishment, it is feedback. Then the optimizer uses that feedback to adjust the parameters. In plain English, it turns the internal knobs slightly toward a more useful direction. After one round, the model has not magically understood anything. It is just a little less wrong. Real learning is many small corrections repeated over many examples. After seeing many samples, the model starts capturing stable relationships. For example, too little sleep may hurt performance, and high homework completion often points to better results. But this relationship is not the same as memorizing one row. Memorization copies the past. Useful knowledge can transfer to a new case. For a model, knowledge is usually not stored as a sentence. It is compressed into numerical parameter settings. Those settings preserve patterns that appeared repeatedly in the data. So data turns into knowledge through at least three transformations. Data becomes representation, representation produces training feedback, and feedback becomes reusable patterns inside parameters. Here's the first trap. More data does not always mean more knowledge. If the data is full of errors, bias, repetition, and noise, the model may learn a very stable misunderstanding. Second trap, correlation is not causation. A model may notice that ice cream sales and drowning incidents rise together, but the hidden cause may simply be hot weather. Third trap, training data comes from the past. The model learns patterns from environments it has seen. If the environment changes, its judgment can break. Good data is not just large, it should be accurate, broad enough, reliably labeled, and close to the future problem we actually care about. When a new sample arrives, the model turns it into the same kind of representation, then uses the patterns stored in its parameters to make a judgment. The whole pipeline is the world leaves records, records become representations, representations enter training, training rewrites parameters, and parameters support new decisions. That is why data engineering matters as much as model training. With poor ingredients, even a talented chef can only cook something strange. A practical habit is to ask four questions. Where did the data come from? How were labels made? What was filtered out? And does the future case really look like the training case? One final question. If a model learns very carefully from biased data, is it gaining knowledge or just becoming better trained at repeating the bias?